Hello, everyone who is attending Science Alive in 2021. I'm Professor Randy Ruchtis from the physics department at the University of Notre Dame, and I'm professionally a high energy physicist and an experimentalist. And one of the things that I enjoy about the work that I do is the development of new particle detector instrumentation. And I'd like to tell you a little bit about it. I have a detector here that I'd like to show you today that allows us to see some interesting particles that are all around us, passing through us all the time. And we don't know it because we can't see them. And they are subnuclear particles. And you're going to have a chance to see them, and I'll talk about them here a little bit today. This instrument that we're going to be using is under this cloth that you can see right here. And there's a video camera over on this side that's recording the images that are being displayed on the screen up there near me. And the instrument is right here in what's called a black box. And that black box is there just to keep room light away so that the system can operate quietly. And the key element of this instrument is a specialized piece of glass that looks like this. And I'm going to try to hold it up for you. It's about the size of, it's about an inch on the side, and this one's about a ½ inch deep, and the one in the box is about an inch deep. And it's a plate of glass, but it's a plate of specialized glass, which are little filaments. So imagine you took your hair and lined it all up in one direction and put literally 1 million of those hairs all together in a bundle, and they could all transmit light. And that's what that glass plate is, specially polished. But the glass is a special glass that's able to respond to the light that's created when a high energy particle might go through it. And what's interesting about that for us is the following. Our Earth is a special place. And we're protected by living on the surface of the Earth, because protecting us from all kinds of particles that are coming, called cosmic rays from outer space, are out there, and the atmosphere of our Earth act as a protective layer, and the magnetic field around the Earth, and you've probably all held a compass or seen one, so we know that the Earth has a magnetic field. That magnetic field also helps to collect particles that could harm us. And so we're protected by those, but some of them are able to penetrate down to the surface of the Earth, and those particles are electrons or muons. Muon is a particle which is 200 times as heavy as an electron and has similar properties, but they're very different particles. And that's one of the beautiful things that we study in the field of particle physics. And you can actually see those. Those particles come all the way down to the surface of the Earth. They're passing through our bodies, and some of the time they pass through this unit over here. And when they do, then on the screen up here, you will see tracks that correspond to those particles that are passing through. And this scale that you see there, that scale size looks very large here. It's about the size of a couple of my hand lengths, but it actually is 1 inch. That image that you're seeing corresponds to the 1 inch of this plate that you see right here. And it's just been blown up by the video camera, so you can see things nicely. All of these flickers here correspond to electrons that are created in this detector itself. But when a particle goes through that glass, then we see a nice track, and the plate is recording the presence of that track. And then when you see one of those, it's most likely a muon. And muon is named after the Greek letter M for mu, is the Greek letter. So anyway, interesting, and this is our circumstance. Now I'd like to tell you a little bit more. This instrument is very compact and can be carried, so it could go anywhere. You could take it home and have it in your kitchen and look at cosmic rays in your kitchen. You could go to your basement. You could go somewhere else. And several years ago, this instrument was taken to a very large particle physics laboratory in Europe, in Switzerland, near the city of Geneva. It's called the Large Hadron Collider Laboratory at the International Laboratory CERN, C-E-R-N in French. And I'm not a very good French speaker, so I mostly just talk in English. Anyway, a team of people here from our group, led by Professor Dan Karmgard, two high school teachers, Professor John Taylor from Elkhart Memorial High School, and Mr. Brian Dolezal from St. Joe High School in South Bend, and a high school student at the time, James Twaddle from Marion High School in Mishawaka, all went as a four-person team over to Geneva to put this instrument that you see right here in a high-energy particle beam to see what would happen. And in that case, they could see muons going through because there are muons in Europe just like there are here. But instead of this particle physics laboratory, they should be able to see particles that are coming in from the particle beam at the accelerator and creating interactions in this instrument. And they were over there and took data for 24 hours. And I'd like to show you some of the exciting things that they saw when they were in the beam. So I'm going to now shift over to my seat here. And I'm going to be now screen sharing so that you can see a video that they recorded while they were there. So bear with me. Okay, so now what you should see in the image is another TV screen. They were looking at it. And behind this fence that you see, and a few meters away, everything is in metric units in Europe, but for us, it would be a few yards away. There was the detector placed in a particle beam, and they're behind this safety fence so that they're away from the radiation. And now I can run this video and you can see what they saw. So instead of particles coming in through the top, you can see particles coming in horizontally from the beam because the beam is moving horizontally through the plate. It's very bright because the particles are extremely energetic and also multiply charged. So that's a combination that leads to a great deal of light creation in this plate. And what you could see is that they're recording this in real time and they can see it. And you can see sometimes these tracks look super bright, and then sometimes there are these funny things that look like things exploding in the background. And those are hard to see in the video. So what I'm going to do instead is I'm going to show you what they look like in still images that we could record looking more carefully at the data. And here's one of them right here, and I hope you can see it. So you can see at the top of the image, a beam particle went by. It's very bright, it's very heavily charged, and it's got plenty of energy, and it just goes right through the glass as if the glass isn't there. But some of the time, those particles don't get through the glass and they create a particle interaction, which you can see something came in down here at the bottom, right in this location down here. And I'm trying to move my cursor and maybe you can see it. And that beam particle came in and struck a nucleus in the glass of material. And the glass is made up of many interesting elements. And you can see that it created a nuclear interaction and many particles were produced. Some of them come up here in these angles. Some of them go straight ahead, some of them go down, some of them come toward us, some go away from us, and some go backwards as we see it. So this is what we call a high energy particle collision. And it's in these collisions that we can discover new particles. And at this laboratory in Europe, it's very exciting because several years ago, a particle was discovered called the Higgs boson in our Notre Dame group, and high school teachers and students were all participating in the excitement of that experiment because of the research that we've been doing. And they've been included with our research group, and it's called Quarknet. But what was exciting for me is that was something that was discovered in this past decade that I read about as a young boy in school in the early 1960s. And that's when this kind of particle was predicted that it might occur, and it took till now to discover it, and we have discovered it. And several people won the Nobel Prize for that discovery, and one of them was the person for which the particle is named, called the Higgs boson. So an exciting time in physics, and what makes it so much fun for us is that not only do we get to do the work which excites us as particle physicists, but we also, at the same time, have a chance to include students and high school teachers and students and others who are interested in the research that we do as part of the research team. Exciting for all of us. So thank you very much for your attention today, and have fun at Science Alive. Thank you.